All right, so today I wanted to take a small example based on some feedback I got from a colleague before that was about sort of why you might want to write unit tests to help you with something. And I figured I'd start with a really simple example that can kind of illustrate a case with sort of two challenges that people will generally face. So it's a super simple example. Um, but we're going to look at a couple gotchas that sometimes people will come across, especially as they're writing code. And if they're not used to setting things up to be unit tested, if they're not thinking about some of these things as they're going, sometimes it can be a challenge afterwards where you're like, oh, I want to go add unit tests to this. Oh, but I have to go change a bunch of code. If you think about some of these things ahead of time, they can help you actually, as you're programming, you keep them in the forefront of your mind, and you start designing code in a way that enables you to write unit tests. So uh, I have a really dumb and simple example here, but I think it will help illustrate a point. So the idea is that I have this class called a console calculator. Why we would have this, I'm not really sure, but I think it's going to help to prove a point here. And we have one method that's public on it that's called add, and it takes in two numbers, num1 and num2. It will take the two numbers, add them together, store the result in a local variable here called result, and then it's going to write to the console. And what it wants to write out is the number 1 that you passed in with a plus sign and some spacing in between, the number 2 that you passed in, some spacing with an equal sign, and then the result that was calculated. So pretty easy. I think this is a good example of, a small method that we could write a unit test where I'm giggling because it's ridiculous. But yeah, I think let's go ahead and take some steps for trying to write some unit tests. So I had another video up that was trying to show how to add the NuGet packages and set up your projects to do it. I don't think that you can see my context menus as I'm clicking on stuff, so that kind of sucks, but I'll explain what I'm doing. So I'm going to right click in my solution. I'm going to add a new project. So I kind of jumping back and forth here. You can't even see the window that comes up. That sucks. I gotta change my stream settings and stuff. But anyway, again, like I said, I'm gonna walk you through what I'm doing. I'm adding a new class library, and I generally will name it like the name of the project that already exists that I'm trying to test for. So unit test simple system, and then I call it like .tests. Okay, so I'm gonna add that. I'm just double checking here. Yeah, so you can see this new project that was added. I have a class that automatically goes in called class 1. And in order to test the class that's in my other project, this console calculator, I'm going to, again, you can't see my context menu, sorry, but I'm going to add a reference to the other project. So that got added here, right? You can see it has a dependency on unit test simple system, which is great. And that means that we can start writing tests, almost. I guess we should add in xUnit. So we're going to manage our NuGet packages. I like using xUnit. There's a lot of other things you could use. xUnit's my preference. I've used it for a long time now. Really big fan of it. It's simple for me. It's never not been able to do what I want it to do, so I stuck with it. So I'm installing this xUnit package. Let's go ahead and put that in there. Let NuGet do its thing. Already done. And the other thing that I need when I'm working in Visual Studio, because I don't have a test runner, I need to install the NuGet package for the test runner for xUnit for Visual Studio. If you have something like JetBrains or something else that lets you run your tests, or if you like running them on the command line and not inside your IDE, by all means, go do your thing. I like using this test runner. What that lets me do is I have this test explorer, and I don't have any tests, but what I'll be able to do is make a test, and it should show up in my test explorer, which is pretty powerful because I like having everything right in my IDE, and then I don't have to think about jumping to other spots and running other tools and things like that. So I'm going to change this class 1 to be called console calculator tests.cs. It wants me to rename it. Makes sense. Very cool. Now, what I was explaining in the other video, and I'll repeat it here, is the way I like to organize my test classes. If I'm just running tests on a specific class, which you should try to keep your unit test files organized to only really be exercising one class. I like doing a instance variable, right? So an instance variable for the system under test. I haven't added the mock NuGet package. It's something that I'm going to explain why we're going to want to use that. So what I like to do is make this initialized in the constructor. To reiterate why I like doing this, it's because if I have multiple test methods in this example that I'm walking through, I will not. I'm probably only going to focus on one for us today. But the reason I like doing that is so that if I were to have 10 unit tests and they're all going to be on this class, instead of me having 10 different methods that are going to initialize this the exact same way, because there aren't even input parameters in the constructor, I'm just going to do it once. And then all of my tests, if you're not familiar with xUnit, for every test method we have, it will go run the constructor again, right? So you're not dealing with a stale instance between your test runs unless you made this variable static. We don't even have state in our calculator, so it's not the end of the world. I'm just kind of calling these things out so you can think about them. So we're making a test method. Naming convention that I like to use looks kind of like that, and I'll explain. So this first part will be the name of the method we're testing. This will be sort of our conditions, and this part here will be our output that we're expecting. And we need to label with an attribute fact so that xUnit knows that this method is a test method. And I just went ahead and added the using statement at the top here for xUnit. And the method that we're going to be calling is add, right? So I'm going to go ahead, put that little prefix here. Now we want to think about what our test is going to do. Without thinking too far ahead, maybe I just to prove something really simple here, I want to add 1 and 2 together, and I should get the number 3. Great. Okay. The other thing I mentioned in the other video was that we generally will put these things in order where we arrange, we act, and we assert, right? So arrange is your setup. This act part is actually like the actual thing that you're trying to test, and then assert is check your results. If I could type properly, here we go. So technically this line, I'm just moving it. We don't really have any setup, right? Like we've already set up our class that we're trying to test up here. There isn't other setup in this test yet. So we just want to be able to run this, add 1 and 2, but I want to check that it worked. Now, how do I check that this works? This add method doesn't actually have a return value on it, right? We have a console calculator. Like I said, I don't know why anyone would ever want this, but we have a console calculator. We want to figure out how to test that it actually worked. Well, what's it do, right? So if I jump back to this class, we said that the console calculator is going to add these two numbers together and write out to the console. But how am I going to test that, right? Like I give it some inputs. It's not giving me an output. The return method's void, and it has the side effect of writing to the console. So do I go write something kind of crazy that hooks up to a console and tries to read back the information from it? Like that seems a little bizarre. If I'm not allowed to change the API that this console calculator has, I can't have a return value. I mean, we could do that, right? So why not? Like just to help prove a point here, let's say, you know what, console calculator, we're allowed to change the API, and we can do this. Return result. Cool. So now we have something we can assert on, right? So var result, and then we can put our assert check at the end here. And we do expected and then actual. So 1 plus 2 is hopefully 3 on a good day. And we'll compare that to our result. And great, yeah, like we just checked that this works. Or did we? one of the requirements of this console calculator is that it has to write to the console, right? So if we know that that's supposed to be an expectation, right, what we're trying to prove here is that console calculator, we're going to add 1 and 2, returns 3, and prints to console. That's kind of like what this method is supposed to do for us when we pass in this input. But the challenge here is that even though we had the luxury of changing the API, we can prove that it returns 3, but how do we prove that it prints to the console, right? We can't really, with the way things are set up. And the reason we can't is because when we're writing unit tests, what we're trying to do is prove that the internals of what's going on in the method we're calling are actually happening, right? This console write line is a static method on console. So we actually can't check that without doing some crazy things like trying to read back from the console or something like that. So just a little tip is that when you're writing code in C# and you're finding for anyone that I've worked with or programmed with, they might hear me saying like, oh, like don't put static stuff in there. The only reason why is because when you have things that are static methods, including extension methods, because they're static methods, it makes writing your unit tests a little bit trickier, right? So yes, we were able to prove that even with changing the API, we can check the return value of adding 1 and 2. However, we're unable currently to check that this behavior works. Okay, so one thing we can do is trying to break this apart a little bit. And this is a pattern I like to use when we're interacting with like what I would call an external system. Now, this is kind of a bad example of that because console write line isn't really an external system, but a good example of this that I've used, in real world examples when I'm programming is, say, interfacing with a console application. So I want to call a third-party program, and I want to call it on the command line, and I want to read back the results. When I'm writing unit tests for things like that, I don't want to have to actually call some external system, right? I want my unit test to be very focused on the actual things I'm running, and I like separating out the systems, the pieces that are interacting, so that they can be tested on their own. I do want to have a conversation, probably in another video still, about how you can, like what the drawbacks of doing that are and ways that we can work around that. But when I'm focusing on unit tests, they're very much for a unit. So this pattern that I like to do is something when I'm interfacing either with static things, when I'm interfacing with external systems, command line things, anything that's not part of my class that I don't really have control over. That's what I mean by an external system here. So what I like to do is look at what this is doing, right? I have something that's console write line. What if I had control over this, or I moved this into something that I felt like I could trust? Well, what I could do, I'm just going to tell you, is I would make another class and I would call it console wrapper. Okay, and this console wrapper, I'm going to say public void write line, and it's going to actually write stuff out. Now you're probably thinking, why does that help us at all? You still have all the same code, except now you have this other dumb class. Yes, okay, so you're totally right. What I'm going to do, again, you can't see my context menu. I'm right-clicking. This is just something in Visual Studio. You can do it manually. I'm right-clicking on the class name. I'm going to go to Quick Actions and Refactoring, and you can actually do something called Extract Interface. So I'm going to make this new interface just called iConsole. Okay, so it made a new file for me. If I jump over to it, you can see I have this iConsole interface with write line on it. Okay, might still be wondering, how does this help us at all? Currently, it doesn't do anything. Doesn't really do anything at all for us. I'm going to move this other class we just made, console wrapper, to another file. So you can see over here, I have console wrapper, which implements an iConsole. An iConsole has this one method write line on it. Now, if we jump back to console calculator, instead of me trying to directly interface with this external system through, in this example, console, where I'm writing a line to it, I can say, you know what? My class doesn't actually need to know how to directly talk to the console. That's someone else's job. My job is to add, and I need to tell someone who can write to the console to go write some stuff. So what we can do is we can take in this dependency, console calculator. It's going to take in an iConsole. Okay? And what we can do, again, I'm just doing a little bit of, you probably can't see the context menus here. I'm doing just a quick refactor to take this as an instance variable. Now what I'm going to do is this. And you still might be wondering, how does this help us at all? You still have this external system you're calling. But the cool thing that this does for us is that we've just said that we don't actually care how it's writing to the console, just that we're telling someone, go write this to the console for us. And that's an interesting advantage that we now have. And the reason why is when we're writing unit tests, we're actually trying to decouple the implementations of the systems. You might be wondering why there's an advantage of that. You know, what happens in the real world when all these systems are working together? Yes, there's other types of tests for that that we're not doing right now. But in order to unit test that this is actually doing what we want, we have some control now. And the reason why is we can provide a different implementation to console that we can control. Right? And that's kind of a weird concept, but what we're going to do is use a mock. We're actually going to fake that we have an iConsole implementation by using a mock. Okay, so we're going to go ahead and do that. And to do that, we have to jump back to our tests. And you're going to see like this thing's complaining now, right? It says, you know, it has an underlined squiggly. And the reason why is we're not passing in an iConsole anymore, right? This is supposed to take a console. It needs one. If you were writing something like a functional test, what you might do is do var console equals new console wrapper, right? Now it's happy, right? It's not complaining, but this doesn't solve anything for us. We still can't prove that it's writing to the console. So when we're writing unit tests, because we're focused on our one part of the system, in this case, I'm jumping back to this class over here, this console calculator, we're just focused on what we see in here. We're delegating this other work out to WriteLine. So what I'm going to call out right now, and maybe I'm jumping a little bit ahead, is I'm acknowledging, console wrapper, I'm totally acknowledging at this point that this class, to put unit tests on it, I haven't solved the problem. I have not solved the problem that I don't really have a good way to read back from the console and prove that we wrote the line out. I don't. But what I'm going to say is I'm trusting that from the perspective of this class, I'm trusting someone else has an iConsole implementation that works, right? So this is an assumption, and that's why just writing unit tests for everything is not going to solve all your problems. It's helpful. It's not going to solve all your problems. But if we assume that someone's giving us an iConsole implementation that works, we don't have to test it in here. Someone else is supposed to write the test for that, at least to prove that this line works. Again, proving that this line works with some other test and proving that just this stuff works in our own test does not necessarily prove that two implementations work together. That's a different conversation. We're just focusing on putting a unit test here. I keep reiterating this because some of the feedback I hear when working with people when I'm explaining unit tests is, yeah, but when you put them together, you don't know what's going to work, or what about these side effects? And I like to reiterate it that you're right. I'm not saying that we should not put the other tests in. I'm just saying that these are one type of test that is valuable because we can prove that we're hitting the lines of code we expect and calling them the way we want. So, okay, just jump back to the test. We've now passed in a console wrapper, but we have the same problem. And the problem is that I can't prove that this line got called. And in our unit test, it's a white box. We want to know everything that's happening inside of it. And I can't, I'll prove it this way. Here's an interesting example. So I'm going to run this test. I think it should pass because we know that 1 plus 2 is 3. If I jump back to here, 1 plus 2 is 3, and it goes into result. We're returning result. This test will pass because it's not actually checking prints to console. So I can right click on this, run the test, and if I jump over to my test explorer, you can see because I have the xUnit test runner for Visual Studio, it's a NuGet package, it shows it, and it's taking its time. Oh, it says test run finished. So maybe I messed something up. I'll try it again. Oh no! This would happen when it's live, right? Why isn't it running my test? I don't know. That's not good, but that was something that would happen live for sure. Oh, I know what it is. I actually wrote a blog post on this and I didn't listen to my own advice. Okay, so you can't actually have a xUnit project that is .NET standard. You need to have an actual framework. So for anyone that just missed what I did there, I went and edited the project file. It used to say Net Standard 2.0. I'm telling it a specific framework. And the reason why is that your tests have to target a particular framework. Okay, that's how xUnit works. So that was embarrassing, but good thing I remembered my blog. And now when we go run this again, it should pass. Or still not do anything. Oh my goodness. Okay, I think it might need to be tricked here. So I'm going to unload it and reload it. If this still doesn't work, I don't know. We're done. Run tests. Let's try one more time. Build canceled. Why? Pardon me. It says not compatible. Project unit test simple system is not compatible. You know what? Okay. Let's change this one too. I don't actually need these things to be .NET standard. I added the projects and I wasn't thinking. Okay, I'm just rebuilding these things, making sure they work. They've rebuilt. That's good news. Let's try one more time. We're going to run these tests. Cool. I like doing this stuff live because when I have little mess ups like that, I like proving that it's not rehearsed and that like there's ways, these kinds of things come up all the time when you're programming and you should have ways to work around them. So this test passed. So now we're back on track. Sorry about that. This test passed and that's nice, but we're not checking this behavior. And to prove it, I'm going to comment it out, right? This test, I'm betting, is still going to pass. And it does, right? We have a green check mark. So what I'm trying to illustrate here is that, again, this is a bit of a poor example because I've come up with this really contrived kind of dumb class, the console calculator, I know. But the point is that in this example, I'm showing you that someone, if you're thinking about either you're working on your own projects, changing your own code, or even more relevant is when you're working in teams and you always want to make sure that other people can come into your code, change it accordingly, feel safe to change your code, that there's test coverage, and that way that you're not having these blocks of like, I have to be the gatekeeper, I'm the only one who can touch this code. You want to be able to collaborate. And when you're set up in a way that people can accidentally change things like this, like I just removed one of the core pieces of functionality from this class. It's supposed to print to the console. I just removed that and my tests still pass. That's pretty scary. So what I would like to do is show you how you can change this test to actually prove that we're hitting this line of code, right? So I started by saying, let's extract this interface. We have a wrapper. But if I go back to the test, I'm just going to click this here, jumps us back. If I go back to the test and I look, we're passing in the real thing still. And that's not what I want to do for my unit test. I mentioned mocking earlier. So let's actually add a mock NuGet package. So I use mock, which is MOQ. I believe there's probably plenty of these. I really like mock. I've used it for a long time. Big fan of it. I have not used other mocking frameworks. So I can't really compare and contrast this with other things, but mock has done. I've only encountered a few oddities over years of using it, and I can always work around them. So it's not really an issue. So I'm going to show you how I like to set up mock. So mock has basically the ability to give you a dummy implementation of an interface. Okay, and you can control what happens when people interact with this interface. Sounds kind of weird, right? So what we're going to do is we're going to make a mock. It's called a mock repository. Okay, and you can ask the mock repository to create you a mock of some type. And then with that reference, you can set up the calls that you want to allow to happen on that mock. Okay, so first off, again, I like structure. I'm showing you how I structure it when I'm writing multiple tests. Mock repository. There we go. I have to say it out loud when I'm typing it because I'm probably going to mess it up when I'm typing it and it's recording. So mock repository. Oops, there we go. And I'm going to instantiate that here in the constructor. And the mock behavior is going to be strict. So what strict mocks mean is that when you create a mock off the repository, it will have this behavior by default. And a strict mock, if you don't set it up, will throw an exception. So it tells you you're running this test code and you never did anything about this. And I'm actually going to leave it as strict. And I believe that your unit tests, when you're trying to prove that lines of code are getting called, require you to have strict. If you have loose, which is the other option for mock behavior, you're essentially saying, I don't know or care what's going to happen when you call this line of code. Now, for a unit test, I would say you do care. I can't think of good reasons why you don't care in a unit test. If you're doing other types of tests, sure. For a unit test, I think it should be strict. I would love to hear different opinions about that. I'm always open to hearing these different perspectives so that I can try applying new methods. But this is how I've been doing it. Now, what we're going to do is we're going to get rid of this console because we want a mock one. So private read only mock iConsole, right? I'm going to call it console. So it looks like before. And to make it, we're going to say mock repository. We can say create and ask for an iConsole. There we go. Awesome. Super simple. This is still mad at us. Why? I said mock repository, give us a console, and it gave us one. But if you look, I don't think my IntelliSense shows, but if you look, underscore console is declared as a mock iConsole. And this console calculator wants a console, not a mock iConsole. So you can actually say console, oops. The other argument was that I actually was missing the underscore, but it's still not happy. There we go. Sorry, there's a typo. You can ask to pass in the object. Now everything's happy. Okay, cool. So now we're giving it a mock console. I mentioned something about doing setups, and we haven't done that. But just to prove to you, let me just double check what code we left in the console calculator. So this is uncommented. This is back to the original code. Very good. I'm going to run this test. My prediction is it fails. And the reason why it fails is because I made a strict mock and I did not set it up. At least my tests are actually running now. That's good news. Okay, and it failed. And why did it fail? It says mock exception. iConsole write line 1 plus 2 equals 3. The invocation failed with mock behavior strict. All invocations on the mock must have a corresponding setup. So it's what I mentioned. We didn't put the setup on. So let's go ahead and do that. And fortunately, we left this little spot for us to go ahead and add this setup. I know it's super exciting. This is how you would call a setup method. So you give it a signature. So x dot. Oops, what's going on here? Oh yeah, I was expecting a calculator. It's not. It's the console. My apologies. So what do we actually expect to happen, right? I mean, the answer is over here. It said we actually called it this way. Like we tried to call WriteLine with that. Okay. Awesome. Now, what does it return? Nothing. You can't even type returns on here. If WriteLine had a return type on it, this would let you type returns like whatever you want, right? But it doesn't. So we can just prove that this thing's getting called now. Okay. So what's interesting about this is that I'm going to run this. I expect that this should pass now because I have an idea what's going to go on. And you might too if you're familiar with this or it's making sense. This should pass now because we've set up this mock. Doesn't need a return value. We're passing in 1 and 2. Based on our last test run, it told us it wants to do this. And we know that from before, it's still going to return 3. So this should work. Then, hopefully once it works, and I didn't make a typo anywhere. Cool, so it worked, great. We can try proving this other example from the beginning where we said, well, what happens when you or someone else is coming through your code and you're like, that's dumb, why do we have a WriteLine in here? Like, calculator should just return things. And I don't disagree, it's really weird to have a WriteLine in here, but this is a console calculator, and its requirement is it's supposed to output to the console. If we go run this test now, should it pass or fail? It passes. So, oh no, we didn't solve the problem that we wanted to solve, right? And that's because we said in this test, set this thing up for us. And it goes, okay, I'll do that. But then no one called it. It doesn't care. It's like all that this said was make sure that this is set up. And mock is like, sure, okay. But if no one calls it, it never cares. So a thing you can do that's really powerful is mock repository verify all. And what this will do for you is every mock that was created off your repository, it says, if you called setup on here, was it actually run? Right? So I left this commented out. All that I did was add this verify all call. And now this should hopefully protect us, right? So your setups kind of work one direction. Your verify all works the other direction to make sure that your setups are called, right? And now it's actually saying, hey, look, you told me that you're expecting this thing to go run, right? That's why you set it up. You set this thing up on purpose, hopefully. So if we're verifying your calls, it's going, hey, you know what? Nope. Like you set this thing up, no one's actually calling it. And if your test failed for this reason, you might go, uh-oh, okay, well, so you come across this error output somewhere in a build system or you're running your test, whatever, because maybe you're the one who changed it locally. And you go, that's kind of weird. And you're looking at this setup. So from wherever you were in your code, you jump over to this and you're like, okay, well, I see that we're setting up this WriteLine. And that looks right because we're supposed to add 1 and 2. I know it's a console calculator. It should be writing this to the console. Okay. It's telling me that it's not actually getting called. So you might jump into this class and you'd say, it would probably not be commented out, but maybe someone did this. And you're like, oh no, this implementation actually doesn't write to the console. Interesting. So at that point, it's a good conversation to have with someone to say, you could see who last touched this file and you say, you know what, did you mean to remove that? Is it truly the expected behavior now, the new expected behavior that this should not write to the console? Or was it an accident, right? Should it actually still write to the console? And they might go, oh, crap, you're right. That was an accident. Or maybe this is you reflecting on a code change you made yourself. It's more often than not the case. And you go, oh, crap, you know what? This is a console calculator. Oops. Someone did actually expect this behavior. They literally made a test for us that checks this expected behavior. So I'm going to make sure I don't remove that. I'm going to go run this test again. And if this doesn't pass, I'm going to be concerned. I'm not prepared if it doesn't pass. Cool, it passes. So good news. Great. Okay. So having the setups for the things that we're trying to mock out, help, right? Because we're saying, I expect this to get called when we run this test. And the verify all call kind of works from the opposite direction for us and says, yep, I verified that the thing you set up actually ran. Which means if someone was like, you know what? Well, what happens if I say, I'm going to set this up and I want to say that the first thing this thing's supposed to do is saying like, cool, nice output, right? I have this extra setup in here. What should happen? Should it pass or should it fail? Let's find out. I wish this like happened a little faster so it wasn't such a dumb wait in between, but okay. So it says the verification failed. I know this is a super dumb example, I'm sorry, but it says that you set this up and no one actually called this. Right? No one actually called this. So the verify all call is a really nice way to make sure that you don't have these extra setups in here, that you can keep your test setup just focused on the things that are part of your unit test. So that keeps it nice and organized. But I think strict mocks and verify all calls work really well together for actually making a unit test that proves line by line what's going on. Okay, so almost wrapping up here. I think one thing I wanted to call out is that what we went ahead and did was prove that we can exercise the body of this method, but what we never actually did was prove that we can write to the console. And this is in my opinion, a really nice strategy when you're trying to work on systems that you're saying like, hey, I can't put unit tests on here because I have to interact with all these other things. Like, okay, what we just added, in my opinion, is way better than no test at all, right? Because now someone can come through here and they might do this. Our test will catch that, right? Someone could do this. Our test will catch that. Before, if you couldn't even put the tests in because you're like, well, I'm interacting with this console, I can't prove it, you had no tests, right? Or you put the tests in and you just pretend like, I don't know how to prove if it calls to the console, so someone could accidentally remove this line. It's a dumb argument because it's the console. However, if this was an external system that you were calling out to and you're like, well, I don't know how to prove it's doing the right thing, so you never check for it, someone could easily modify that code and your test isn't going to catch it. So in my opinion, being able to do this little step of pulling out these external systems, putting a little wrapper interface in front of them, right? That's all we did. Made our own little wrapper for it. Yes, I know it's an extra class. It's an extra interface. Yeah, that sucks. But you know what doesn't suck? We just wrote a unit test that proves that we called these lines of code, right? And that gives us an ability to have confidence in what we're calling, that we have scenarios that we can prove what we're running. And I think that's better than not having any coverage at all, right? It gives you some protection to allow other people and yourself in the future to come through a section of code, change it, and go, oh, I just modified expected behavior. And you know what? That's okay, because maybe I'm kind of thinking about some examples off the top of my head. Maybe someone was like, you know what? I've been looking at the requirements of console calculator, and it really sucks that it has these extra spaces in here. That looks dumb. Okay, I'm going to go change that. And they would go say, okay, well, I'm about to go commit my code, and our awesome build system is going to go run these tests for us. I'm just jumping back and forth here, sorry. Right, okay, so I'm going to go run these tests because I just made this awesome code change. The output's going to be way better, and everything should work. And they go run it, and they go, oh, crap, it doesn't work, right? So the unit tests that we're adding, because they're checking the lines we're calling are as we expect, it's brittle, right? And I've had conversations with people about this where people say tests shouldn't be brittle. You know, it's more maintenance. You're actually adding dependencies this way. I don't disagree with the fact that now you have a test that's literally dependent on some code, but I think there's different types of tests. And in this particular case, I personally enjoy the trade-off of having a brittle test like this And the reason why is because the code change to actually fix the test is done, right? I just fixed this test as I was talking about it. So when you have things like unit tests that are brittle and break easy because of code changes, as long as you're keeping your methods small and your unit tests focus, usually the changes, as I just proved, to update them and fix expected behavior are very lightweight. If you, on the other hand, had a very large test like method that you wanted to test and you had a lot of setup for it, right? And you had a lot of tests that were exercising the same bit of code, and then you change some expected functionality, all of a sudden your test maintenance goes way through the roof. So it's really important that when you're adding unit tests, you're trying to keep them focused on small methods. You can break your methods up into smaller pieces. So focus on small methods. Try to have minimal setup, and then yeah, like otherwise you're going to run into problems where all of a sudden to make a little change, like removing some spaces, like I just did, you have to go modify like 50 lines of code scattered everywhere just to fix something dumb like that, right? So hopefully that gives you a good example of like how you can refactor some code to extract what I call an external system from the perspective of the class and method you're working with. How doing strict mocks with setups coupled with verify all can actually give you good confidence that the code you're running is doing the right thing, and a good example of how you can use xUnit and mock together. I've said a couple times I really like to be able to illustrate how functional tests can kind of help you in parallel with some of this stuff. So I'll try to come up with an example of that. But I think for now, I think that's about it. So hopefully that was semi-useful, and thank you.